Okay, this is section 4.1, geometry, page 283. And we begin, this whole chapter is based on triangles, okay? And so then we move it on to different figures in the future. We start out with a very basic theorem that you probably already heard. It's called the triangle angle sum theorem. The triangle angle sum theorem. It says the sum of the angles of a triangle is 180 degrees, okay? So if you take a look at this triangle, we're just going to apply this to you. If you ever cut the angles off a triangle, you can put them together and you will see that it forms a straight line because 180 degrees is a straight line. This is angle 3, this is 28 degrees, this is 1, this is 57 degrees, and this is 71 degrees, and this is 2. What I would like you to do is, based on the triangle angle sum theorem, is to try to figure out how big A is, or excuse me, how big 1 is, how big 2 is, and how big 3 is.
Is that it?
This is angle 1, the measurement of angle 1, the measurement of angle 2, and the measurement of angle 3. We need those in degrees, correct? Okay. So, can anybody tell me the angle, the measure of, what would be the easiest one to find and why?
1.
1 would be the easiest one to find,
Yeah.
based on this theorem?
Yeah, you could just subtract 180 by 57.
Okay, but that's not using this theorem, is it?
No.
No, okay. Which would be the easiest one to find using this theorem? 2, okay. And how big is 2? How much? 52? Can you see that?
Not really.
Not really. Nice.
Which one's angle 2? It's the...
This one right here. Better?
Yeah.
Okay, so that's 52 degrees, correct? Okay, now, we cannot use this theorem to find angle 1, so, Nelcha, how big is 1?
123.
123. Do you agree? Alright, so if this is 123 now, we should be able to find angle 3, correct? And can somebody give me the value of that?
$29.
29 degrees? Do we agree with that?
Yeah, 29.
29 degrees. Okay, so let's take a look here. This is a new picture, but still kind of using the same theorem. This is angle 4, this is angle 5, this is angle 6, 7, 8, and 9. You'll see that 8 and 9 are marked equal. That's how we mark them equal. Remember those little arcs? Okay, this is 57 degrees, this is 58 degrees, this is 65 degrees. Okay, now based on this, what would be the easiest angle to find? 7. Okay, because we have 2 of the angles given, and so how big is 7? This is 65, this is 58. She says that angle 7 is 57 degrees. Do you agree?
Could you read? Sorry.
This is
Yeah.
65 degrees. This is 58 degrees. This is 57 degrees.
And then what about the bottom?
This is angle 8 and angle 9, but they're marked congruent. That's how those arcs are. Okay? Can anybody tell me a different angle? How big is 5? Angle 5. This is 57 degrees. How big is angle 5? Ooh.
57.
Why? Tell me why. Because they're vertical angles. So this is 57 degrees. Okay. And then how big is 6? Can I take 180 and subtract 6? Okay. And how big is 180 minus 7, I should say. 180 minus 57 is what?
123.
So angle 6 is 123, correct? All right. So we have 123 here. Okay, let's start with 4. Can anybody do 4? 66 degrees, thank you. All right, so we have 8 and 9. How do we do 8 and 9? I'm a little confused on how to do that. Anybody got any ideas? None whatsoever.
What is,
See these arcs? They mean that those two angles are equal.
You do 180 minus 66, and then you get that answer divided by 2.
Why 66?
Because angle 4 is 66, and then these
Well-
two have big triangle.
Oh yeah, but angle 8 only goes to here. Doesn't go across here. But could we do the same thing you're talking about here?
Yeah.
Could we take 180 minus 123? So 180, so it'd be 57. Notice that 57 would equal 8 and 9 put together, right? So how do we get 8 and 9 then? Divide by 2, and 57 divided by 2 is 28.5 degrees. 28 point, and they're both 28.5 degrees, okay? So notice that 7 was equal to 8 and 9. Does that seem interesting? I have a question for you. 7 was equal to 8 plus 9, right? Tell me, 6 right here. See, 6 is 123. Is that equal to angle 4 and 57? 4 is 66 and 57. Well, that's weird, isn't it? Because this angle that's outside this triangle was equal to these two, and this angle was equal to these two, wasn't it? And they're both just outside the triangle, aren't they? Think that's a coincidence? No, it is not a coincidence, which brings us to our next concept. Take a look at this figure here. I have drawn this. This is called the interior of the triangle. Do you see this triangle here? This is called the interior of it. Does everybody see that? Is there anybody that does not see that this is the interior of this triangle? It has 3 angles, 1, 2, 3, right? Angle 4 is an extension of angle 2. Do you agree with that?
Yes.
All right. Angle 4 is called an exterior angle. That's why I put EXT. It's called an exterior angle. Okay? It is supplementary with which one? 1, 2, or 3? It is supplementary with 2. Thank you very much. And tell me what 1, 2, and 3 add up to? 180. Well, it turns out that we have what we call the exterior angle theorem. And it says the measure of an exterior angle of a triangle is equal to the sum of the measures of the 2 remote interior angles. 1 and 3 are called remote interior. Do you know what the word remote? If you go to a remote island,
There's nobody there.
oh, actually
It's
it
like
means
kind of hidden.
it means away. It means away. So 4 is an exterior angle for these 2 remote interior angles. In other words, if I add 1 plus 3, I get 4. Do you understand that? So the measure of 4 equals the measure of 1 plus 3. Do you remember from our other picture here, I'm going to put this in real quick, that we had the same thing going on. We had angle 7, 57 degrees equal 8 plus 9. Do you remember that? All right, same thing with this, is that we have angle 4 is equal to angle 1 plus angle 3. And it says, remember, angle 2 and 4 are supplementary because they form a straight line. They're 180 degrees. And 1, 3, and 2 are add up to 180 degrees because they're inside of a triangle. And 4 replaces 1 and 3 because they are equal. So it all works out around that concept of the exterior angle theorem. Now, we're going to do this one. We have 2x minus, oh, by the way, up here, if I was to put this angle here, is 5 an exterior angle? It is. And so what would it be equal to? 1 and 2. And I could extend this side too. And I could say, oh, this is 6. What would 6 be equal to? 2 and 3. So every exterior angle of a triangle is equal to the two remote interior angles added together.
Is that 2x minus 48?
What's that?
Is that 2x minus 48?
This is 2x minus 48 degrees, 2x minus 48 degrees. This is 32 degrees, this is x degrees. It says find the measurement of angle FLW. So FLW, oh, I forgot to put my labels in, didn't I? What would you know FLW? I'll show you what FLW is as long as I can find it. They want you to find, this is F out here. This is L. And this is W. So they want you to find this angle here, this angle here. In other words, they want you to find the 2x minus 48. So using the exterior angle theorem, how could we solve for that? Using the exterior angle theorem, 2x minus 48 equals what? Using the exterior angle.
Why don't you take x plus 32
That's correct.
equals...
What's wrong? This is 32. So x plus 32, this angle plus this angle equals the exterior angle, this angle. Does everybody see that? Tyra?
What is that last, or what are all the variables?
This is 2x minus 48.
Okay.
This is x, and this is 32.
And then find the measure of...
Find the measure of FLW, angle FLW, which is FLW, this angle right here. Right there. So, Aubrey said that 2x minus 48 was equal to x plus 32. Do you agree? Okay, so we can solve then, this is plus and negative, and we can subtract x from both sides. So we get x plus a negative 48 equals 32, correct? And now we subtract a negative 48, which is the same as adding 48, isn't it?
Mhm.
So x equals 10, 80. Okay, so x is equal to 80. That didn't answer our question. I just said that this was 80 degrees. Now we gotta figure out what this is. So we gotta put the 80 back in, correct? So we take 2 times 80 minus 48. What is that? 160 minus 48, which is what? So that FLW from here to here is 112 degrees. Questions? Kagan? Delcha?
No, I'm sorry.
Okay, are we good?
No, not yet.
Okay.
Is that x equals...
80. That's just the value of x.
Yeah.
We wanted to find the angle. Okay. We good? All right. These pictures are in your book also. Actually, this one is not. But, the first two I showed you are in your book. Okay, so on page 285, it talks about a corollary. C Corollary. Corollary is a postulate. Postulate, if you remember right, a postulate is a statement that is proven, or not proven congruent, but we've never found a counterexample. So a corollary is a postulate that follows a theorem. So if you have a theorem, it says these follow directly from that theorem. So it basically is a postulate. I just wanted to know if they ever used the word corollary to you, that you understood that a corollary is just a postulate that follows a theorem. Okay, in other words, something from the theorem we've moved on from the theorem and it came from that. Okay? So these next two are corollaries. This one, they're called the triangle angle sum corollaries. So they actually came from the triangle angle sum. Let me remind you what the triangle angle sum was. The triangle angle sum theorem said the sum of the angles of a triangle is 180 degrees, right? Okay, so these come directly from that. The first one is the acute angles of a right triangle are complementary. Okay, if I have a right triangle, okay, this is 90 degrees, correct? So what do these have together? Have to be? They have to be 90 degrees. So they are complementary. All right. The other thing is there can be at most one right or obtuse angle in a triangle. You can only have one right triangle because if you have two 90-degree angles, you're already at 180, right? That leaves no room for another angle. If you're over 90, obtuse, you can't have another obtuse because then you're over 180 again, and it has to have three angles. So therefore, these two corollaries come directly from the triangle angle sum theorem. You got it? All right. Now, of the two, this one you use the most. The acute angles of a right triangle are complementary. All right? Okay. So now we're ready for the assignment. All right? And you're going to be doing types of problems that you've already done. We're on page 286. I'll have Cheney write it up on the board. Page 286, numbers 12 through 32. It is due tomorrow. I'm giving you plenty of time to work. Okay? All right. Page 286, 12 through 32.